All right, you guys, I want to look at part 2 here on assignment number 2. Okay, I started making a video already and then the camera died, so that's why there's stuff on here. Okay, so these are all in slope-intercept form already. So remember that our slope here is 1. Sometimes people tell me the slope is x, but x is never part of the slope. The slope is always just a number. So we got to assume there's a 1 in front of the x. Okay, so my slope is 1. My y-intercept is 2. So just like we did with regular lines, I'm going to start at 2 on the y-axis, not on the x-axis. And if my slope is 1, well, that just is 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. And remember, we do the exact opposite. Down 1, left 1, down 1, left 1. Okay, so now the difference is we've got to decide if we should have a solid line or a dashed line. Okay, it's kind of like the open circle, closed circle thing. So what I do is I look at that inequality right there, and it has a little equals on the bottom, which says it can be like the solutions can actually be on the line. It can equal those points. So I'm going to make a solid line. If there wasn't a little equal sign there, that would tell me, that little line underneath, that would tell me it's a dashed line. Okay, now we often call this the boundary line because there are infinite solutions to this thing. The thing is that the solutions are all on this side of the line or they're on this side of the line. And we don't know which side that they're on. So a good little trick, I guess you would say, is to do a test point. And usually we pick 0, 0 as our test point. And we see, is 0, 0 a solution to this inequality? Now remember, coordinates have x and a y. So we go right up here, let me get rid of this, and I put 0 in for x and 0 in for y. Well, if I put 0 in for y, it's 0. I'm going to rewrite this, less than or equal to. I'm going to put 0 in for x. 0 plus 2 is 2. Now, I see if this is a true statement. Is 0 less than or equal to 2? Yes. Okay, so that is a true statement. That means that that point right there is a solution to this inequality. Now, the solutions are all on the same side. It's not like some are on this side of the line and some are on that side of the line. So if this side's a solution, then this whole side is the solution side. And that's the side that we shade. Now, when you do this, you don't have to make it like super, super dark, like some people really like to shade that, because then it just rubs out all over the place. But do shade it enough. Like sometimes I'll see people put like just this, no. Shade it good enough. Okay, now remember what this tells me. It says if I picked any point on this side of the line, and it could be a point in there, like that I don't know the coordinates of, any point on this side of the line will make this a true statement. Any point on this side of the line will make that a false statement. Okay, now let's see where our solutions are. So remember how the quadrants go. Quadrant 1, okay, so you start with positive, and then we go counterclockwise. So 1, 2, 3, 4. Okay, so there's some solutions in quadrant 1. There's solutions in quadrant 2, and actually sometimes people go, oh, there's just a couple in quadrant 2. There are actually infinite solutions in there. Okay, so some are in 1, 2, 3, and 4. And because it's got little equals, any point on that line would also be a solution. So my solutions are in all 4 quadrants, and they include the boundary line. So all 4 quadrants includes the boundary line. That's my solution. Okay, so box 1, I'm going to put an A. Oops. Okay, let's do one more. We'll go through this one a little bit quicker. Okay, this is my y-intercept. So on the y-axis, I'm going to put a point on -1. Here's my slope, 2/3. up and to the right. So from -1 up to over 3. And then remember, I can do the exact opposite. Down to left 3. Okay, now I got to decide, is it a dashed line or a solid line? Well, since there's no little equal sign right there, that tells me it's a dashed line. A dashed line means you can't have solutions on the line. The solutions can be really, really, really close to that line. We actually say infinitely close to that line, but they can't be on the line. All right, now I got to figure out where to shade. Are all of the solutions on the top of this line, or are all of the solutions on the bottom of the line? So again, I'm going to check my test point. 0, 0. So let's see. Let's plug in 0, 0. So 0 for y. Okay, well, 2/3 times 0 is 0. 0 minus 1 is -1. Okay, let's see. Is 0 less than -1? No. So this is false. Or we could say not a solution. Okay, well, if this is not a solution, that means none of the solutions are above the line. So the solutions must therefore be below the line. So it's going to look, they're all down here. Okay, so let's see where they're at. Well, there's some in quadrant 1. There's no solutions in quadrant 2. There are some in quadrant 3 and some in quadrant 4. Now, this is our boundary line. If it's dashed, we say excludes the boundary line. It's excluded. It's not part of the answer. Okay, so we need 1, 3, and 4, and excludes the boundary line. So that answer is Y. Okay, I hope that gets you started if you were a little bit stuck. I'll see you guys tomorrow.